In this video, we will be creating the Poplar Clipboard Project. If we take a look at our project plans, we need our finished size to be 9 inches wide by 12.5 inches long. This clipboard project will consist of 5 individual boards that will be glued together to make one larger board, which will serve as our clipboard. When we take a look at selecting lumber, we can choose a big wide board, or we can choose to use some smaller pieces. Because our project plans show that there are 5 smaller pieces, each measuring 2 inches in width, we just need our boards to have a minimum width of a little bit over 2 inches. If the board that you select has knots or other defects, this might not be a good piece to choose, as with a clipboard you need to be able to have a flat surface to write on it. And if there is a big knot or a hole in the lumber, that could cause difficulty when writing on it. Additionally, if we take a look at our plans, the width of the clipboard is 9 inches. If we were to choose a board that already has a width of 9 inches, we might run into a situation where over time the board will cup. If we were to use the wider board, we would still need to cut the wider board down into smaller pieces, as noted in our project plan, so we could still use this material. We could also use this smaller reusable waste material to get our 5 pieces out of. Now, although my finished length is 12.5 inches, when I lay out each of these pieces, I'm going to lay it out to 13 inches, which will give me just a little bit extra material. We want 5 pieces that will be 2 inches wide by 13 inches long. The current width of my board is just under 10 inches wide. When we begin cutting this, we want to cut off a little bit on the miter saw to square up one end. I'm then going to measure my 13 inches and create a second mark. This mark will signify a miter saw cut, and at this point we are just laying things out in chalk to see where these pieces are going to come out of this larger board. So I'm going to have a piece that is 2 inches, a second one, a third one, and a fourth one. Now, this board being just under 10 inches wide will not yield me enough width to get a 5th piece out of. So this remaining lumber will end up being waste material, which also means I will need to do an additional miter saw cut and get an additional 2-inch piece out of it. So I have my first miter saw cut to square it up. I have my second miter saw cut that will get me a smaller board to yield 4 pieces, and then I have a third miter saw cut that will yield me that one additional board that I need. The remaining material becomes reusable waste. When we get to the miter saw, we want to make sure that the good edge of our board is going to be up against the good, clean fence. Our rough edge of the board needs to be facing away from the fence. With regards to the chalk lines that we drew, when we get to the miter saw, the chalk lines mean nothing. Do not follow the chalk lines when you are cutting on the miter saw. We want to remeasure and ensure that we are using a pencil with a sharp tip. Now, because the lumber that we get from the lumber yard is not perfectly square on the end, we need to first square up the end by taking off just a little bit of material. After that, we can measure and mark our board at 13 inches. By cutting the board at 13 inches, we will be making our first smaller piece of material that will yield us 4 2-inch wide pieces. And because we need one additional 2-inch wide piece, we will be measuring and marking our board at an additional 13 inches. After cutting this piece, we should have enough lumber to build the entire project. At this point, we have 2 smaller boards. One edge is pretty good, but mill marked from the lumber mill. The other edge of our board is rough. Prior to cutting our 2-inch wide piece on the table saw, we need to clean up one edge of each of these boards. So I'm going to be cleaning up the better edge, so I only have to send it through the joiner 1 or 2 times. If you clean up the rough edge, you'll end up sending it through the joiner 5 or 6 times, which is a waste of time. After running each of my boards through the joiner 1 time, I have one good, cleaned up, jointed edge and one rough edge. I always need a good, cleaned up, jointed edge before I can run it on the table saw. On the table saw, I'm going to set the fence to 2 1/16 inches, and I'm also going to make sure that my good, clean, jointed edge is going to be pressed tightly up against the good, clean, perfect fence. With each of my boards tight up against the fence with that good, clean, jointed edge, I can cut my first 2 pieces at 2 1/16 inches wide. On my work pieces, I now have 2 good, clean, jointed edges. I have 4 mill-marked table sawed edges, and I have 2 rough edges. If you take a close look at the mill-marked edge, you can see burn marks in many cases, and you can also see scratches if you look closely. Anytime the edge of a board touches the table saw, that becomes a mill marked edge, or it has mill marks. These mill marks will show up on our project down the road, or it might cause us problems when we go to glue up our project. Either way, we need to address the mill marked edges. Two of the pieces that I have cut measure 2 1/16 inches. For right now, I'm going to set those pieces aside and focus on the remaining pieces that I'm working with. Of my 2 remaining pieces, I no longer need one of them, as the rest of my pieces will come out of the other. On this piece, I have 1 mill marked edge and 1 rough edge. Before I can run this piece through the table saw to cut an additional 2 1/16 inch piece, I need to run the mill marked edge through the joiner one time to clean it up, to clean off those mill marks, and to make it square and true. I now have a good, clean, jointed edge and my rough edge. This will allow me to put a good, clean, jointed edge up against the good, clean, perfect fence on the table saw and get my next 2 1/16 inch piece. After running my board through the table saw, I have a good, clean, jointed edge and a mill marked edge on the piece that I cut off, which is 2 1/16 inches wide. I'm going to set this piece aside with my other pieces, and what I have left is again a board that has a mill marked edge and my rough edge. So I am again going to run the mill marked edge through the joiner before I cut my 2 1/16 inch piece on the table saw. Following the same pattern, I have a good, clean, jointed edge. I have 2 mill marked edges, and I have my rough edge. I'll set aside my 2 1/16 inch piece. The remaining lumber, after joining it, I can get an additional 2 1/16 inch wide piece once I've cut it on the table saw. I now have 5 project pieces. One edge is jointed and cleaned up, and one edge is mill marked from the table saw on each of these pieces. Additionally, I have some leftover material that I could use for a future project. With my 5 project pieces, they each measure 2 1/16 inches wide, but they have a mill marked edge. After running each of these pieces through the joiner one time, it will clean up the mill marked edge, and it will remove that 1/16 of an inch. Each of my work pieces now measure 2 inches wide by 13 inches long. The 2 inches width is our finished measurement before glue, and the 13 inches long is our oversized length measurement. Our objective in creating these 2-inch wide pieces and then gluing them together is to prevent the clipboard from cupping or bowing or twisting over the life of the project. To do this, we need to alternate the end grain for each of these pieces. This way, the lumber will naturally fight against itself, preventing it from cupping or twisting or bowing. Taking a look at the end grain of the lumber, we want to identify the direction of the growth rings. And we can do that by drawing on top of the edge of the lumber the direction that the growth rings are going. Some of the boards, it is easier to tell. And then we have some boards here where it looks as if the growth rings are going diagonally. We want the boards to alternate grain direction. So if we take a look at the boards currently, our boards are going up, up, diagonal, diagonal, down. We want an alternating grain pattern. So definitely we would want the first one going down if it is sitting right next to one going up. The boards with grain essentially moving diagonally are a little bit of a wild card, and you can kind of place those wherever you would like. This current orientation should be sufficient for this part of the project. The next thing that I want to take a look at is the face grain pattern. Ideally, when the boards are all squeezed together, we don't want to see those glue joints. That is kind of the perfect scenario. Although sometimes you might want to have a varying color pattern if, say, two of your boards are more greenish and the other three are more whitish. But in general, we want all of the boards to fit tight, and we want the grain pattern to flow with each other. Now, when you put all of your pieces together, if you have large gaps that do not close, it could be an indication that you did not joiner the edges very good. So we would need to take the boards back through the joiner and clean up whichever edges are causing it to not squeeze tightly together. This one looks pretty good. Taking a look at this, we have nice wide grain on this piece. This piece we have a little bit tighter grain, but between both of the pieces, the grain is going pretty straight. So when those are together, it pretty much looks like one piece. If we take a look at this piece over here, we have some grain that has a little bit more curvature to it. And the piece next to it is kind of curving the opposite direction. So it is possible that maybe we want to slide that one to the other side. And the grain pattern here is a little bit straighter, so we can see that that blends together a little bit nicer. My grain pattern here also kind of curves down in this area, whereas I'm going straight here. And this one we got kind of a little bit wider grain. It's never going to be perfectly matched because we are essentially making a big wide board, but you always want to come back and check the end grain to make sure that we are still alternating grains. Now, we were fortunate enough that we had a couple pieces with that grain that was kind of going diagonally, that we can shift stuff around and not be too worried about not having that alternating grain. But we always want to check the end grain. We always want to check the face grain. If at that point everything looks good and we're happy with the way that it looks, we're going to number our joints. 1, 2, 3, 4. And this is going to help us remember what pieces went where when we go back to the glue table. To glue up our project, we will be using 3 clamps total, beginning with 2 clamps on the bottom, and we will add 1 clamp later on the top. Now I have oriented my boards so that my numbers match up, 1, 2, 3, 4. I double check to make sure that the end grain is how I want it and the face grain is how I want it. And flipping up each board, I can run a bead of glue along the edge of the board. And I'm going to spread that glue around and make sure I get good coverage over the entire joint on each board. I can then flip each board down back into position. And making sure that the ends are lined up, I'm going to very gently snug the clamps. With my ends pretty good, my face pretty good, and both of my clamps snug, I'm going to add a 3rd clamp. A little bit of pressure. Double check that nothing moved on you, and then I'm going to snug all of the clamps evenly. You don't want to over tighten it. We just want it nice and snug till the glue starts squeezing out and the clamps are on there where they're not going to fall off. After that, we want to use wet paper towel to wipe both the top and the bottom of our workpiece where the glue squeezed out of. The more glue you can wipe off at this stage, the less work you have to do later. At this point, we need our project to sit in the clamps for 24 hours until the glue cures. After letting our workpiece dry for 24 hours, we can unclamp it and put the clamps away. Our workpiece glued up pretty good. If we take a look at the back side, we do see where there are some locations that the glue did not get wiped off underneath where the clamps were sitting. We're going to take a scraper and scrape off any excess glue. When the glue dries, it does dry like concrete, and running dried glue through the equipment will dull the blades. So we want to make sure we have as much glue scraped off as possible. According to our project plan, we want the finished thickness of our clipboard to be 1/2 inch thick. Currently, as it sits, my workpiece is about 13/16 thick. So I will be using the thickness planer to size down the thickness of my workpiece. The design of the thickness planer is such that the knives are located on the top portion of the planer. So when I send my board through, I'm going to make sure that the worst side is face up, which will then clean up that worst side as the knives are located on the top of the machine. After each pass, I'm first going to measure the thickness of my workpiece to make sure I have not gone thinner than my 1/2 inch measurement. I'm then going to bring the machine down a 1/2 turn and run the worst face up again. I'm going to continue this procedure until my workpiece has been thinned down to a 1/2 inch thick. When finished, my workpiece measures 10 inches in width, which is an oversized measurement, by 13 inches in length, which is also an oversized measurement, by a 1/2 inch thick, which is my final thickness measurement. Now, because the width of my workpiece is 10 inches, which is an oversized measurement, we need to bring this down. If we take a look at our project plan, we want our total finished width measurement to equal 9 inches. As it currently sits, our 2 edges have been jointed, so they should be cleaned up and true. However, since we had clamps up against the edges of the board when we glued it together, those clamps may have marred the edges. So what we are left with are relatively good edges that may be marred by the clamps. We want to choose one edge to run through the joiner to clean up that edge, just in case it was damaged by the clamps. After having jointed one edge, that edge is cleaned up and true. Our other edge is still marred by the clamps. Additionally, our width is over our finished 9 inches width measurement. We can then place that jointed edge up against the fence on the table saw. I will be setting the table saw to 9 1/16 inches. This is 1/16 inch larger than my finished width measurement. This will give me an additional 1/16 inch of material to take off during the next step. At this point, I have removed about an inch worth of material. I can go ahead and set that piece aside. My length is an oversized 13 inches. My thickness is a finished 1/2 inch. And with this workpiece, I have one good, clean, jointed edge and one mill-marked table sawed edge because I just ran that through the table saw. I'm going to clean up this mill-marked edge on the joiner, which will also remove that 1/16 of an inch worth of material. And I am left with a board that has a finished width of 9 inches. If we take a look at our project plans, we want our clipboard to have a finished length of 12.5 inches. Currently, our board measures 13 inches in length, which is our oversized measurement. Although I did a pretty good job gluing up my board, there are a couple areas where the ends are not perfectly smooth. The board's got off just a little bit. We need to clean these up which is precisely the reason why we added that extra 1/2 inch worth of material to begin with. To do this, I'm going to begin by removing the smallest amount of material on the miter saw just to square up one end of my workpiece. I can then flip my workpiece over and measure it to 12.5 inches and put a mark there using a pencil that has a sharp tip and make my cut. At this point, my workpiece has a finished length of 12.5 inches, a finished width of 9 inches, and a finished thickness of 1/2 inch. If we take a look at our project plans, we want a small radius on the corners of our clipboard. To create this small radius, I'm going to use a small cylindrical container, position that near the corner, and trace around the bottom of it. Moving over to the bandsaw, we can eliminate those corners by following our line. However, we want to make sure that we stay about 1/8 inch away from our line on the bandsaw. Leaving a little bit extra material will allow us to bring this down on the sander and do a much better job of finishing that curve than we can get on the bandsaw. And we can then clean up those corners on the stationary sander. And with those corners cleaned up, our clipboard project is looking pretty nice. All of the edges of our project have a very sharp edge, and it is not very comfortable to hold the clipboard with those real sharp edges. If we take a look at the project plans, we can see that there is a small roundover on all of these edges, all the way around our project. To accomplish this, I have a small radius roundover bit installed in the router table. I will be running both sides of my workpiece through the router bit. This will put that small radius on every edge, but I will be applying downward pressure with a push block near the blade to ensure that I get a good consistent cut. And when our first side is done, we can flip that over and do the other side. And at this point, we are looking pretty good. At this point in our project, we need to sand all surfaces to prepare this for the finishing phase of this project. If I take a look real close at the edge of the project, there are some burn marks from the router. I need to sand off these before I continue. Any radiused edge that we ran through the router, we can sand by hand and smooth down the edges as well as clean up any burn marks. If I take a look at the face of my board, I can see just a little bit of a line right here. That is end snipe caused by the planer. Additionally, I can feel just a little ridge in the face surface of my board. That is caused by a small chip in the planer knife where the planer didn't cut that portion. And to clean up these faces, we will be using a palm sander. After we have finished sanding our project, it is looking pretty good. It is smooth. All of the burn marks and other issues have been cleaned up, and we are ready to lay out for our hardware. If we take a look at our plans, our hardware components are located towards the top of our project, centered. We first need to determine which side we want to be the front and which side we want to be the top. I do have an area on my project where the grain pattern doesn't look the best. For this reason, I'm going to have this surface be the top of my project. And the reason for that is because with a clipboard, you typically have papers covering that top surface of the project. As you're holding it, people actually see the back of the project, and the back has a lot more character than the front does. So I'm going to have this side be the back, and the side with my kind of grain issue, that will be the top or the front. Using a tape measure, we want to determine the center point for our hardware, and we also want to figure out where vertically we want that hardware to sit. If it sits too low, we are not able to hang up the clipboard, and there's a good chance our papers will fall off the bottom. If we have it too high, we don't have enough material to screw the screws into. So we want to find a good medium point vertically, and then obviously we want it to be centered along the top. After marking those hole locations with a pencil, I'm going to take a screw and I'm going to set it right in the center of my hole location. I'm going to give it a little tap with a hammer to put a small divot right in the center. Essentially, I'm using this screw as a scratch-all to put a small divot in the center of the hole location to help prevent the drill bit from walking when I start drilling. And using a 1/16 inch drill bit, I'm going to drill about halfway through my project at both hole locations. I'm going to install a couple temporary screws into those hole locations. And using a small length of wire, we can create a hook that will help us in the finishing process. After having prepped my project for finishing, I'm going to work through the process of applying polyurethane. I have my project sitting on some painter's pyramids to help elevate it off the table. I also have my hook that I previously made. Because I am applying polyurethane to both sides of the project, I will use the hook to hang the project while it is drying. And using a brush, we can work with the grain to apply our first coat of polyurethane. The first coat will soak into the pores of the lumber pretty quickly, so we will use just a little bit more polyurethane for this first coat. I like to poly the entire project and then come back with the brush and make long brush strokes across the entire project to help give the finish a little bit more consistency in its look. We also want to make sure we get around the edges of the project and up by the screws. If you do have excess polyurethane, you can come back and soak that up by making long brush strokes. Then we'll flip the project and continue on the back side. And when finished, we're going to let it sit for a couple minutes and then go back and check for any inconsistencies on both sides of the project. And if everything looks good, we can hang our project to dry for 24 hours. After drying for 24 hours, we can retrieve our project. And if we feel the surface of our project, it feels fairly rough. Because the first coat of poly does not get absorbed into the lumber at an even rate, it leaves inconsistencies in the finish, which create this rough texture. So with just a little bit of very light sanding, we can smooth down the inconsistencies. And we're going to then apply our second coat. The second coat will go on a lot smoother and a lot faster because at this point we have sealed a good portion of the lumber, so it is not soaking in as much. We're going to coat the top, the edges, and the bottom again. After that, we can wait a couple minutes, double check it for drips or any areas that we need to smooth out, and we can hang up our project to dry again. After allowing our project to dry overnight, it should have a much smoother texture. And we can go ahead and remove the screws and the wire. You'll want to save the screws because we will be using those to attach our hardware. We can position our hardware in the correct location and start both of the screws and then come back and snug those down. And at this point, our project is complete.